Hello again, YouTube, and sorry it's been a while, but there are more important things than making videos because life. But anyway, this video is about the Zaon MRX. Is it MRX? Zaon PCAS MRX. So this is a passive collision avoidance system that sits in an aircraft. So a little GA airplane, and it picks up the transponder emissions from other aircraft transponders. So this relies on having secondary ground radar to interrogate them transponders around it. It picks up them signals and then tells you how far away and at what height difference it is. So we turn it on, PCAS. So this is a very basic system. It's quite old now, and batteries are low. And so what you'd get here, you get a range, say like 4.5 miles, and then a height difference, so say plus 300 feet, minus 200 feet, or zero. And it would beep at you every time it saw new traffic, and if it got within a certain window, it would beep and go mad. But it wouldn't give you a bearing or a direction. You just have to look everywhere for traffic that's 2 miles away. So it is limited in that, and that's why it's gone out of favour. And there's a new system called, like, you've got Pilot Aware and what's the other one? Sky Echo. And these systems, well, Pilot Aware can broadcast a message and interrogate other aircraft and then get their response, and also give you a bearing, because it gives you, with this new transponders aircraft have now, they get a GPS signal, and you know your GPS signal and all that jazz. But anyway, regardless, waffling now, this is out of date, so let's take it apart. So I'll turn it off, and it's very crudely made, the way the case is. So you see there, it's all there, and just the way the battery compartment is. Yeah, there, for instance, you see the fit of that is tight, even though it is just a little pushing door. But you can see the plastics on this are not square. Now, whether that's deliberate or just bad moulding, it looks more to me like bad moulding. So I have a feeling this was made, wouldn't say on the cheap, because it's not going to be cheap to build something like this, but it was made in small volumes without spending money on good tooling and stuff, probably. So that unscrews like that. Now what is interesting, this has got its own internal barometer, which I'm assuming what them ports there are for. And when you turn it on the ground, it's in ground mode, and you need an altitude change of, I think it's 300 feet for it to turn into air mode. And that's to stop false triggers on the ground. And that's why we don't get aircraft when it's sitting here on the ground. But there's an internal barometer. It'd be interesting to look at and see how they've done that. Right, let me remove these 4 screws. 4 screws have been removed. And, ooh, that's a bit old school-y. Wasn't expecting that. And that's the inside of the case there. And that's your circuit board. Now that's looking a bit funky, isn't it? I didn't actually expect to see a socketed chip. Is that a PIC 16FA77. Interesting. That there must be your barometer. Is that matched in the case? No, because that's over here. And then there's your LED display. That is not quite what I was expecting. So we actually have a DC barrel jack there. And we've got a linear regulator. Is that a linear regulator inductor, or is it a switch mode? Can't be a switch mode. I thought so anyway. Some trimmer pots. What else do we have? This is all the RF goodness. We'll take this board out in a second and have a look on the other side. Zoom in, see what we've got. Anything interesting. So there's our RF goodness. Crystal. Must be our front end RF goodness. Don't know what that device there is. It's unusual. X-amp, I'm assuming that's an amplifier. Analog devices chip. Yep, some of that. And then your barometer. Yeah. And then a socketed PIC, which is pretty cool. What's under here? One of them. What's one of them? That's an interesting part numbers to look up and then have a look at this. Look how thick that board is. Wow, that is a thick PCB. And then this quite cool LED display. A little tactile multi-rocker switch. Now that board is really thick. Blimey. And then is that a battery? Right, let's take the does the card come out? Let me pause momentarily whilst I get the board out. Wow, look at the underside of that. Look at them. Okay, there's been a bit of work going into it. Also, everything. Look how thick that board is. That is ginormous. I mean, the soldering this must have been a pain. Just the thickness of that must have caused. There's probably a couple of ground planes in there. Yeah, okay, I'll give them something. There's a bit of work gone into this. Some more analog goodness there. Whatever that device is. Let me see the number on that one. And then what's this? Is that a test point? MLT. PPL lock. This is obviously going to be very complicated design, probably. A lot of analog goodness. There's a chip there. Can't just get the number on that. There you go, 9672. Yeah, this is quite advanced, I think. You've got a JTAG lead or some test pointers there. But yeah, it's all controlled by this pick. And what is strange? Why have they made the board so thick? I can't quite understand how thick that board is. It's really weird. It's a very weird PCB. Don't know how many layers there are in there. Probably lots. And then this is an odd device as well down here, isn't it? Let's see if it is a battery. Let's see if there's any charge in that. No charge coming out of that, so that's not a battery. Must be some weird analog goodness stuff. Probably RF voodoo. Lots of RF voodoo in this. And then yeah, so there you go. That's what's inside a PCAS. And it's quite advanced. Have a look at the pressure sensor. Whoop. There you go. There's a number on that for those who want to have a Google later for the data sheet. But yeah, I'm going to do it. Yeah, I'm going to go and have a look. But yeah, no, this is quite interesting. Very thick, very well made. Nice big caps on the bottom. Don't know what they're for. Interesting. Much better built on the inside than the outside. Right, anyway. I'm going to set this back together again and see if it works. Something I've just spotted is look at this. You've got the different voltage routes here. So you have 4 volts. Let me zoom in a bit so you can see. You've got, keep it steady, 4 volts, 6.5, and minus 4 volts. So that's, hello. This is what all this stuff here is doing. This is a boost converter and a buck converter and all that jazz, because it is actually, we've only got a 3 volt input, so it's making all them rails up. So yeah, there's a lot going on here. An awful lot going on here. Well, it still works after its disassembly. And just to show you how contrast is on the outside. The outside this works really. Inside this is really well built, but on the outside, it balls back in there properly because the antenna is lined up with the hole. The power jack, can you see it's offset? So you can't actually get a power jack in there because the case is in the way. Just things like that. So the outside of this, the plastic casing is rubbish, but yet the insides, as you can see, are very, very well built. Interesting. Well, I hope you enjoyed that quick little video of inside there. Maybe one day I can dive deeper in and actually look at some of the signals and voltage rise inside this, because there's probably quite a lot to explore in here. But that'll be for another day when I've got a bit more time and I've had to tidy, because, you know, as always, the shed is a mess. But for now, I'll leave it there. So I'll see you later. Bye for now. And I hope to be making some more videos in the future. I've got a few ideas lined up, but if I get time. Right, I will see you later. Bye for now.